Hi everyone. So keeping with my TV stations in your home lab theme, today we're going to be taking a look at this Extron VSC-200, and it can take a VGA video in coming out of your computer and turn it into analog out, so composite, S-video, and I think just RGB. And let me show you what happens when we flip this thing on. So, nothing. It's totally dead. This was sold to me on eBay as works well. Normally I would just return it, but I've been poking around inside. I got a pretty good deal on it, even if it's broken, and I think we can fix it. So you can see some screws are missing. I've already been looking around. So let's get the lid off and I'll show you what's going on in there. All right, so just a handful of screws on the top sides for the rack ears and the bottom. So let's get those off. All right, so mostly apart here. So the first observation is that this thing is like really well built. So the last thing I had open was one of those blonder tongue RF modulators, and this power supply is so superior in construction to whatever was going on in there. So I'm actually kind of surprised it's not working, and I'll show you why I think it's not working. So let's get it plugged in again, and I'll walk you through the troubleshooting process. So, and again, this is very dangerous. So this side of the power supply over here and these rails coming in, that is enough voltage coming in from the wall to kill you. So be very careful and do this at your own risk. But with that out of the way, all right, I'm gonna reach over here and flip it on. It's on now. It's not doing anything, just like before, like I showed you. So let's get the multimeter out. The first step is to see if we've got voltage coming in. So we'll switch to AC because we're going to measure something coming from the wall. And what we'll do is just stick our probes down in here, and 120 coming in from the wall. So that's good. It's not this connector. Now we're going to switch over to DC. Okay, we're going to measure the low power side. So these heat sinks are usually a ground, so I'm going to make that assumption. And I'm just going to work my way down the pins. So nothing, 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 skipped a pin here, nothing, nothing, and nothing. So we can safely conclude at this point something's wrong with this power supply. The board over here looks very, very clean. I'd be very surprised if one of these components had an issue, though it's still possible. Basically, when you get something that's broken on eBay, well, it should say untested. This guy claimed it worked, but for reasons I'm about to explain, I'm just going to keep it and see if I can fix it. But yeah, the no power situation is usually the best one because it's easy to diagnose, and usually you can just replace the power supply. All right, so we're pretty sure this thing's not working. This is probably very repairable. I gave it a once over, and we'll pull it out again, and I didn't see anything obviously wrong with it. I'm sure we could trace it back from its high power over to the low power side and figure out what's wrong with it. But I'm just going to pull it out and see if we can reverse engineer which voltages were coming out of it, and see if we can power this with something like a small ATX style power supply. So I'm going to pull this out and walk you through how we're going to try to determine what these voltages are coming out of this. Just wanted to show a little tip. So sometimes these have little latches. You can see it just in there, and you can't get your hand in there to unlatch it. But if you use like the old piece of a credit card, you can get it to come free like that. All right, so the power supply is out, and remember what we're trying to do is figure out what voltages it's supposed to be producing here to see if we think it's reasonable for us to find a replacement and get rid of this thing entirely. So one thing that's really easy to do is determine which of these is ground. At least one of them is going to be ground. So you put your voltmeter into continuity mode. So that means when there is a physical connection, it'll beep. And my wife loves it when I'm watching YouTube videos that have this beep going on. So these heat sinks are usually ground. So that's going to be a really easy way to figure out which of these is ground. So basically we just go like this. Remember, no sounds means there's no connection between my two leads. And there we go, we found one. So this is connected to pin 3 over here. If I'm starting from, let's start from the red. So let's call the red pin 1 and we'll work our way over to 6. So 1, 2, 3, 4. Pin 4 is a ground. Pin 5 is another ground. So we have these two are grounds. So we've knocked out 2 of our 6 pins, and that's nothing. All right, so let's start a diagram so we can keep track. All right, so this lovely diagram, doesn't need to be fancy, is this pin header here. So R for red, so those line up. And the second and third from the left were ground. So we know this is ground and this is ground. And so now we need to figure out which voltages, if any, are coming out of pins 1, 2, 3. Let's number them all just because I'm going to talk about them. It's a 6-pin header and we know 2 of them. Let's go to the board, and the strategy is going to be look at some components, look up their data sheets and see what kind of voltage they expect, and see if any of them are connected to our power lines here. I should have mentioned the very first protocol with a power supply is to see if a fuse is blown. This one has a fuse. I was pretty excited when I first opened it up because I thought, oh yeah, I'm a genius, I'm going to fix this right away. This fuse is fine. So something else is going wrong with this power supply. So here I've got the board out of the rest of the case. This is our power header here. So this line from the power supply came in like this. So red is up top in your orientation. So here's our diagram. 1 to 6, red at the top corresponds to this. So we already know that these 2 second and third from the bottom are ground. That's good. We'll confirm that even. Let's see what else we can figure out. So the best thing to do is usually on these power rails, you're going to have them going pretty quickly into some other components. This is a voltage regulator, I think. So it's going to take voltage coming in from the power supply and turn it into another voltage, take 12 to 5 or whatever. So a good bet is that one of these is going to go in here. And sure enough, my best guess is this farthest one probably connects up. It's hard to tell through the traces, but the voltmeter makes it easy enough. All right, so let's come back with our meter in continuity mode and take a look and see if we can find this pin. That was easy. So yeah, this bottom pin is going into the middle pin of this voltage regulator. And now what we're going to do is we're going to look up the data sheet for this voltage regulator, see what power it expects. Hopefully it's a small range, and we'll be able to deduce what's coming out of this bottom pin. That guy is a Motorola 7905 CT. All right, found the data sheet for that voltage regulator. We can see that on pin 1 was ground and pin 2 is the input. So that was the pin that had continuity to one of our power rails coming out of the power supply. And if we scroll down, we are looking at a 79 CT series. It outputs 5 volts. I'm not an electrical engineer, so you always see this. So you'll see voltage regulators on the board. This one takes in some voltage and turns it into 5 volts, even though we already have other rails that are probably 5 volts. So I don't know, does anyone know what that's about? Seems pretty common. Anyway, we care about the input voltage. So here in the data sheet, it says this thing will expect between -5 volts and -18. So probably likely that this thing wants -12, or well, we know this thing can take -12. Probably likely that that rail was -12. All right, so as we saw on the data sheet, this little guy takes in something like -5 to -18 volts. Pretty good bet that this is a -12 rail. 5, 12, -12 are pretty common power rails. So we're going to call that -12, and the first pin on this guy was ground, which was also buzzing when we looked at our grounds, so we've confirmed that these are indeed ground. We have 2 data points to confirm that. So now we'll move forward and see if we can figure out pins 1, 2, and 3. All right, so another useful strategy is to take a look at some other chips you think you'll be able to find the data set for and see if their VCC or power in is connected to any of your pins. And so we'll take a look at this one. Typically, it's one of the corners that's VCC or ground. So let's start in one of the corners. And remember, we know our bottom 3 pins. Let's start with this one, that corner. Ooh, okay. So the top right corner of this pin is connected to this pin header. There we go. Now we can go same story. Let's look up the data sheet for that guy. Looks like that is a TI HC574. No idea what it does. Doesn't really matter. We'll probably be able to find the data sheet for it and figure out what kind of power it wants. All right, the HC574 is, of course, an octal edge triggered D-type flip-flop with 3-state outputs. No idea what that means, nor do I care. So here it is right on TI's website. Pin 20 was VCC. That's the one that we were getting continuity on to some of our rails. And if we continue to look through the data sheet, we can see VCC has an input voltage range of -5 to 7 volts. Safe to bet that's 5 volts. All right, so as we saw in the data sheet for that guy, 5 volts. And also, I didn't get it on camera, but I was sort of messing around with these pins, and I noticed that these two are actually connected. So you can hear the beep when I'm connecting these two. So these are 2 5-volt rails coming in. So now we understand that. And this is where it got a little trickier. So I did find that this guy is also 5 volts. Not much of a surprise there. This is some little firmware, programmable PIC. There's 2 of them on the board. And long story short, I traced this pin, our last one, and it actually connects to here through some capacitors. So it rolls through this guy, some of these surface mount jobs, and I think ultimately this guy connects to this pin. What's confusing me is that these 2 top pins here, sorry, my hands are causing focus issues. These are connected. So that doesn't necessarily tell me it's 5 volts. It could be a higher voltage running. Maybe this weird firmware chip wants 2 voltages. I'm not sure. And it's the same story with the other firmware chip. Super weird. So it was kind of at this stage where I was a little stuck. This was kind of beyond my diagnosing capabilities. And I started to actually turn my brain on, and I thought, well, let's start Googling what's going on with this power supply. Maybe it has some unique identifiers. Because this looks like a pretty top tier power supply. This looks pretty nice. So nice enough that they might have bought it off the shelf. So the serial number did nothing. None of this stuff helped me. But this number down here, 04261 blah, 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 that one brought up a lot of stuff, and it turns out this is a common power supply from the 90s. All right, that's looking pretty familiar, isn't it? I should have just done this in the first place, but you got to come along on that journey, and that's a good approach if you actually can't find the power supply, which is more often than not. Like, this might be the first thing I've ever tried to fix where the power supply was broken, and it's some random equipment like this, niche pro equipment, and it actually had a power supply that I could find by itself. Anyway, so this is the least sketchy data sheet I could find for this bad boy, this LPT 40 series. This is from a company called Aztec. And if we scroll down, we can see that here's our pin header here that we've been drawing out by hand. Red corresponds to pin 1 here on SK2. That's what I've been drawing. Let me I can actually zoom in a little bit. So here's our red pin. And then, of course, it goes down. So 4 and 5 are ground, just like we determined. And apparently there's a few different variations of this guy. So we know for sure, because we beeped out all the other components and looked at their data sheets, we know for sure we have a situation where we have -12, common is another word for ground, and then two 5-volt rails. There's two configurations that can have this LPT42, which leaves us with a 12-volt pin 1, or our red wire. Remember, that's the last one we haven't figured out. Or LPT47, which has a 24-volt wire. So a couple things are pointing me towards the 12-volt version. A, this serial number starts with 042. That is a really big coincidence, given that I'm looking at a part with LPT42 in its name. That probably seals the deal right there. It is a red wire, so it is weird that they would have assigned that a special color, maybe just to make it easier to orient yourself or something. That does point towards something higher, like 24 volts. However, looking at the board, this doesn't seem like high power components. So I'm going to lean on the side of, let's try putting 12 volts over that wire. And that is actually pretty cool because it lets us use an ATX power supply. So an ATX power supply have been the standard in power supplies for, 20 years or something. Don't quote me on that, in PCs. And they make these Pico versions. So this would normally plug into your motherboard, and it produces all these voltages we need, 5, 12, negative 12. And it only takes a 12 volt in. So let's get this on the bench and I'll show you what I'm thinking. All right, so this is what's called a PicoPSU ATX power supply. So this is the normal ATX power supply form factor and connector with all the voltages you would expect, negative 12, 12, 3.3, I think, 5 volts. And they make these really small ones now. So obviously in a traditional PC, it would be much bigger and capable of more power. But you can pick up these really cheap ones that just take a 12-volt DC barrel jack connector. And these are perfect for power supply replacement projects like this. I've been wanting to do this for a long time, never actually done it. Everything up until this point, actually, I'd been mulling over in my head after looking inside the unit for a couple nights. Now we're doing it live. I don't know how it's going to go from here on out. But basically what I'm thinking is I'll just replace that power supply with one of these. And so for your enjoyment, I've drawn out the pieces of this connector we care about. So this little notch corresponds to this notch here. So this pin's negative 12. We've got some grounds. We've got a 12 volt over here, a couple 5 volts, more grounds, and then there's, others that we don't care about. Something important is between this pin 3 and 4 here. I can't remember if those are the actual pin numbers, but at least in my diagram, let's start with 1, call this pin 3 and 4. Remember, this is for an actual PC, so the power switch on the front of your PC would be hooked up to these two pins, and you need to press it for this thing to actually turn on and start generating power. So let me show you what I mean by that. All right, let's power this thing up. You just plug it in. This one happens to have a status light. Okay, so in my diagram, I noted that this was negative 12 and this was ground, and you can see nothing's happening. That's because this would have been connected to a power switch on the front of your PC, and that's what this pin 3 and 4 are all about. So let's short those pins with this wire. So I'm just going to jam that in to the pin, and we're going to pretend that this is a turned on power switch now, basically, with that shorted. And if I take a look at pin 2 and take a look at one of these grounds, we can see we're getting negative 11.7, which is close enough to negative 12 in the digital world. So yeah, that means this thing's turned on now. Let's check our other ones. So we should have a 5 volt here and a ground there. Yep. And one next to it should also be 5. Yep. And then right below that should be 12. Yeah. Okay. So this thing's producing all the voltages we need. Let me show you how I'm going to prototype it into the VSC-200. Okay, so I have the old power connector that used to go to the other power supply. And what I'm going to do to see if this works is I'm going to jam these DuPont connectors in there, and then I'll connect them up to the corresponding pin on the ATX power supply, and then we'll turn it on and see what happens. All right, this is good. This is good. So based on our research, we've got our voltages coming out into the corresponding pins here. I've grounded it to the chassis. There's a ground cable coming out of the power supply. So obviously this is temporary. If this works, I'll get a proper connector for this and just solder the wires directly to the power supply. So these are what's called JST connectors. This is actually the right size here. It actually slides on nicely, but it's only 4. I need 6. I have a kit of the smaller ones. There's a bunch of different sizes. I had the XH. I think this one's called VH. So if it works, I've got a kit coming where I can make my own custom 6-pin, and we'll just solder it on there and clean this up. But the moment of truth, in the meantime, it's plugged in here. Let's flip it on. Oh my God, it worked. Yes, look at that. It really was just the power supply. It appears to be working. Let's get this hooked up to something. So if you're ever looking at some of this sort of pro level AV equipment and you see these connectors, don't be worried about it. These are called BNC connectors, and you're probably more familiar with this RCA style. You can buy these little kit. Well, you don't have to have the whole kit, but I have a kit. And you can easily convert these into RCA. So this pops on the back of this unit and turns it into a plug you might recognize. So just like that. So yeah, that's, never be worried about that. They're just simple 2-wire connections like these. Okay, we're all hooked up. So if I understand it correctly, this thing always spits out composite on this one. So I have this going to input 1 on my TV. And then optionally, you can get it to spit out S-video or RGB or a bunch of different stuff. So I think if I have it in this configuration, it's going to spit out composite as well. Sorry, composite component. So this will be input 1 on my TV. This will be input 5. I'm pointed at input 1 right now, and its VGA is connected to this little guy just running Ubuntu. So let's turn it on. Oh, we're getting something. Yeah, look at that. I can move the screen around with these. I'll put this back together eventually, but yeah, you can move the screen up and down like that. Look at that. That's incredible. Okay, so now the picture is very good, and obviously I'm not going to be able to capture it, but very crisp. All right, so unfortunately I'm still waiting on the parts to make my own connector here. I'm definitely going to do that, and then we'll figure out a way to mount this to one of these posts here, get that all cleaned up and safe. I'll pop out this old AC connector, and I'll probably 3D print just a flat sheet so that I can mount the barrel jack. And yeah, we'll call this fixed. This is looking, I'm just so excited. I really had a feeling when I opened this thing up and the power supply was totally dead, no DC coming out of it, and this thing just looked super clean inside. I had no reason to believe anything was wrong with it. So yeah, I'm calling that a successful repair. All right, I am super satisfied with that repair. Very happy to get that thing working. So it's definitely part of like a bigger scheme I've got to get a bunch of different TV channels hosted off of my homelab rack over RF. In fact, I even picked up yet another RF rack mountable modulator, a blonder tongue one again. So definitely more on that to come. And with this VGA to composite, I'm going to be able to buy or pick up some of these cheap little thin client type, little mini PC deals for super cheap. They don't have to do much, and that way I can get away from having to rely on Raspberry Pi. And I also think I'll probably find other uses for this thing. It's actually a really nice upscaler. I'll do a follow-up video. It actually has a serial port you can control it with, so I definitely want to mess around with that. Maybe hook it up to the secure console. And then one of the reasons I kept it is this particular power supply demands a pretty large amount of money on eBay and if you just Google it. So if I can figure out how to fix it, maybe I can sell it. Maybe I'd put it back in the unit, not sure. But that was one of the reasons I kind of kept it. I thought I could fix it, and it would be fun to use that PicoPSU. I'd never done that before, and that went great. And then, yeah, these things seem to be pretty desirable, so maybe I can figure out how to fix it. So in the meantime, definitely more videos coming, a lot more with this TV stuff. It's kind of my theme lately. And tons of other content on the way. So in the meantime, I'll see you in the next one.